video is on hydrates. A hydrate is a compound with a specific number of water molecules bound to it. An anhydrous salt is the compound that remains after water is driven off of a hydrate. So this is just your normal ionic compound salt. The formula for hydrates is we're going to use a dot, like a big dot there, to connect the formula of a compound to the number of waters per molecule. So if my compound is copper 2 sulfate, CuSO4, it is bound to 5 water molecules, so I write CuSO4 dot 5 H2O to show that it's bound to 5 water molecules. Now on the next slide I'll show you what that looks like. To name a hydrate, I take my salt's name just like I normally would, so I have copper 2 sulfate here, and then to name the amount of waters attached to it, I take a prefix equal to the number of waters, so 5 here is penta, and then for my water I write hydrate. So here I have copper 2 sulfate is my salt, copper 2 sulfate, and then 5 waters gives me penta, hydrate, my ATE ending. There's a couple of different things we can do with hydrates. First is we can calculate the total mass of our hydrate. This is just like how we calculated the total mass of any one of our salts, like my molar mass, but this time I need to incorporate the waters that are attached and however many waters are attached. So my total mass includes the mass of my anhydrous salt plus my waters. So continuing with my example of copper 2 sulfate pentahydrate, I have my mass of my copper 2 sulfate, my CuSO4, 1 copper, 1 sulfur, 4 oxygens. Added together I get 159.62 grams per mole, plus my waters of hydrogen, 1.01 times the 2 that I have, plus my oxygen is 16.00 times the 1 that I have, gives me 18.02 grams per mole. But I have 5 water molecules with that 5 coefficient here. So 5 water molecules, and I multiply my number of waters times 5, gives me 90.01. So when I add these two together, I get my total amount of my mass for my copper 2 sulfate pentahydrate to be 249.72 grams per mole. These 5 water molecules kind of look like this, where my copper 2 sulfate's in the middle, and my 5 water molecules are attached to it, just coming off. Now another thing that we can do with our hydrates is we can calculate the percent of water in a hydrate. Just like I could calculate my percent composition of sulfur in copper 2 sulfate, I can calculate my percent of water inside of my hydrate. Now just like percents before, it's part over a whole times 100 gives me my percent, so my part's going to be my water, my whole is going to be my total mass, times 100 gives me my percent of water. So for my example of copper 2 sulfate pentahydrate, my mass of my water is 90.01 grams. My total mass is 249.72 grams. So I take my mass of my water, divided by my total mass times 100, gives me 90.01, divided by 249.72 times 100, gives me a percent of water in my hydrate of 36% water. Now we're going to go ahead and determine the formula of a hydrate, just given some experimental information. So this kind of brings together empirical molecular formulas along with percent composition and molar mass. So to do this, I have my list of steps that I need to follow. First, I need to determine the mass of my water. Then I need to convert grams of water and grams of salt to moles, just like I would for my molecular formula and empirical formula. Then I'm going to follow the rest of the steps for empirical formulas. Finally, I'll write my formula of my salt dot number of H2Os, and then I'll name my salt with my prefix hydrate after that. So this is kind of typically how it's done, and you're going to do a lab where you calculate your percent of water, and then you can calculate your formula for your hydrate. You have 5 grams of hydrate of barium chloride, and after heating, the dried barium chloride has a mass of 4.26 grams. What's the formula and the name? Well, first I need to calculate my mass of my water. My total mass of the hydrate of 5.00 grams of hydrate minus the dried salt 4.26 grams of salt. The difference between the two, as it was heated, gave off the water. So the amount that was left would be 0.74 grams of water. So that was step 1. Now step 2, I need to convert grams of water and grams of salt to moles. So I have my 0.74 grams of water, divide by its molar mass of 18.02 grams per 1 mole. And that gives me 0.041 moles of water. Then for my salt of 4.26 grams of barium chloride, I divide that by its molar mass, and the molar mass of barium chloride is 208.28 grams per 1 mole. And I get my molar mass to be 0.020 moles of barium chloride. Then I'm here following my steps for empirical formula. My next step is to divide by my lowest number to get a whole number. So 0.02 is lower, so I'm going to divide both by that. And I get 1 and approximately 2. So that means that I have 2 moles of water for every 1 mole of barium chloride. This then allows me to write my formula of salt, barium chloride, dot, and my number of water. So I have 2 moles of water, so 2 H2Os, or 2 water molecules for every 1 barium chloride. And then finally I name it. I have barium chloride dihydrate. Go ahead now and try your practice problems, and your answers are listed at the bottom. Make sure you go through these 4 steps plus naming in order to do it effectively.